to our channel. Let's have a look at problem 3152, special array 2. So in this video, we're going to give a solution following the hint. So let's quickly look at the problem statement. So an array is considered special if every pair of its adjacent elements contains two numbers with different parity. So we are given an array of integers, nums, and a 2D integer array called queries. So we want to check if the subarray corresponding to the query. So the from is the start index and 2 is the end index for the corresponding subarray. So we want to check if the subarray is special or not. So we want to give the answer for each of the queries. So here are two examples. If you look at 0 to 4, that is the whole array. And then we can see that this 2 and 6 actually are same parity, so it's not a special array, so we return false. And here, if you look at 0, 2, so that is 4, 3, 1. So this is the false because 3 and 1 are of the same evenness or oddness. So if we look at 2 and 3, so that is 1 and 6, so they are special, right? So here are some constraints. We're not going to go into details. And here are some hints. So we're going to write a solution according to those hints. So here what we want to do is that we split the array into longest possible subarrays that are special. And then we check for the query if the start and end belongs to a part of certain subarrays, right? So here let me walk you through an example. So if you look at the first example, let's use this one. So this is example 2, right? So we have this one. Then you look at 4 and 3, so they are special. If we want to extend, because this will not be special, so then this we are going to pass it in 0, 1. This is the index. And then if you look at 1 and 6, they're also special. So this consists of another one. So this is the partition of the array. So, and then if you look at the query, so if you look at 0, 2, right? So then the start and end actually covers two subarrays in the other two you can see partitions or intervals. So this corresponds to not special, you get a false. And if you look at 2 and 3, so it's actually within one partition, this one. So this is true. So we can also look at example 1 if we like. So here we have this one, right? So then the partition will be the following, because the 0 and 1 are special. And then because 4 and 1 also different parity, so you get index 2. And then if you look at index 2, and this is also different in parity, so we can also include this one. But we cannot include the 6 anymore, so this is corresponding to 4. So this is the partition, right? Right. So for this problem, the overall solution, it's easy to do this partition, right, by a for loop or linear scan of the nums. But the question is how to do the check. How to check for a query, see, with start and end is within a sub partition, right? So that's actually one thing we want to solve. Actually, we can map every partition to a name. Then we use a dictionary to check. For example, this one. So we can map 0 to so this index is 0, right, for this subpartition. This is 1. So we can map 0, 1, 2, and 3 all to the index 0. In other words, you can name it, and then for 4, actually we name it to be 1. So then when you do the partition, so for example, you do if you do the query, for example, 0 and 4, right? Because 0 is mapped to 1, to 0, and 4 maps to 1. It means that they are not in the same longest possible subarray. So this will return false. So that's what we want to do. So before we do this, actually this problem is dealing with query range. So actually a general method, data structure to solve this problem is the segment tree or binary index tree. So if you are interested in these two data structures, you can also try this one. So for the sake of length of this video, so we are going to explain the first solution based on the hint. In other words, partition, then naming. So our solution here can be summarized as partition and the naming and check. I would say this solution is very specific to this problem, but it also covers some thoughts or ideas. Now let's look at the coding. For the coding, first I want to get the partitions. So then we're going to iterate over this list. So this would be for IY in enumerate nums, right? So then we are going to check if not p. In other words, so we are going to store, so this will be a list of lists, right? If not p, in other words, is start, or so if p is not empty, so p negative 1. So this is the list, the last element, the parity, right? So nums at this index. So modulo 2 equals y modulo 2. In other words, they have the same parity. So in this case, we need to start over a new subpartition. So what we want to do is p append this I, right? And otherwise, so either p is not empty and the last list in the partition and the last element have different partitions as the current number. So we just do p, the last list, append I, right? So this way we get the partition. So you can print out those. For example, 3, 4, 1, 2. So you are going to get these two partitions, like here we wrote, right? So 0, 1, 2, 3, and 4. So now with this able, so we want to, for this one is partition, right? Then let's do some naming. So we're going to use a dictionary, right? Then for I and the partition in enumerate p. So here I'm using the index of each subpartition as their name, but you can use any distinguishable names, that will be okay. So what we want to do is for index in p. So we are going to do the index map to the name. So that's it, right? So we can also print this one. So here for the same example, for 0, 1, 2, and 3, we are going to map them to be 0. And for 4, we are going to map it to 1. So this is the second part. So now let's prepare the return. So this is actually very straightforward now. Then we are going to iterate over the queries. So for start end in queries. And then we are going to check if start and end have the same name. If so, it means that they are in the they are a subarray of a special longest possible special subarrays, right? So if ds equals d of e, right, then we're going to append the result with a true. Otherwise, our result will be appended with a false. So this way, actually, we have the final state of the result list to return. So just return it. So this covers the full solution based on the partition naming and the prepare return solution. So let's do a test. Yeah, it passes the two test cases. So now let's look at the generic case. Yeah, it passes all the cases. That's basically about it for the video, and we want to emphasize that for this kind of problem related to query range, so you can also try data structures like segment tree and binary index tree, right? So you are encouraged to try to solve this problem using these two data structures also. With that said, I guess that's about it for the current video. Thank you for watching.